Hello, everybody. Thank you for joining us today. My name is Emily Kuda, and I'm Percona Senior Manager of Marketing Programs. We're going to get started in just a moment. First, I just want to conduct a little bit of light housekeeping. Can you raise your hand using the hand icon located in the control panel to let me know that you can hear me okay? Oh, great. Okay. Next, during this webinar, you will be on mute. If you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we're going to take time to answer as many questions as we can. Also, in addition, you will receive a recording of today's webinar along with the slides within 48 hours. So with all of that said, I'd like to thank you for attending today's webinar as we talk about choosing the right open source database presented by Percona CEO, Peter Zaitsev. Take it away, Peter.
Hey, thanks, Emily. Hello, everyone. And today, indeed, we are going to talk about choosing the right open source database. And in this talk, I kind of split it in two parts. One, we will talk about the aspects of choosing the open source database specifically, right, based on some high-level technology questions and some others. And then I also have a bit of a section about the understanding the open source licenses, right? Because once we talk about open source databases, I thought it would be good to explain that in a bit of details as well. So now, first of all, is this talk is not about choosing open source, right? I believe for most people attending this talk, that is probably self-evident of what open source technologies, everything being equal, are better than proprietary technologies. And I think that is the so common wisdom in the industry. I don't have to talk about that much more. But now, if you want to have some ammunition to convince someone, I'm going to offer you some pointers. First, let's look at the very common measure of open source databases, the DB engine ranking. And we can see here the top 10 databases. And what is interesting in this case, while you have 2 out of top 3 databases are Oracle and Microsoft SQL Server, you can see what they are losing ground, and majority of databases which are gaining the ground are open source databases. Now, I would also point out what this DB engines ranking is based on methodology which includes a lot of different data points, and which also include how much pretty much measures, among other things, how much marketing is done around those technologies. And obviously, proprietary databases typically have much larger marketing budgets than open source ones. Again, by this measure, we can see what over a period of the last 5 years or more, the open source databases have been gaining the ground on the commercial databases. Now, what I find this very interesting is also this survey, which is a Stack Overflow developer survey, right? Which is surveying just the developers about what exactly database technology they would like to use. And what is interesting in this case is what the Oracle, which had a top spot on the DB engines, is not even in a top 5, right? Because developers are not really very excited in writing new applications to Oracle, for Oracle, right? And what you can see in this case, the only proprietary database, which is here, is a SQL Server. This is because obviously Microsoft and .NET Stack and so on, they still have a substantial followers among developers, especially Stack Overflow crowd. So interesting question you should ask yourself is, are you looking to choose the database, as the title says, or are we going to be using databases, right? Multiple of them. Now, reality is what every database has certain cases where it's is particularly strong, right? And where it is not going to be a perfect fit. And a lot of that comes from engineering trade-offs, right? Because if you, for example, building a database using the column store to optimize for a lot of reporting applications, then you are going to have a problems right with the OLTP applications, right, which are much better suited for row store format. Right. Now, what you also may find is what a lot of large-scale applications, right? Go pretty much here to any talk out there about any large service, right? Ranging from Uber to Pinterest, and you will hear what they are using multiple databases, right? Or often it's referred as a data store, right? As well, maybe having that a little bit less formal than databases. And what we hear in this case a lot is about is a term about the polyglot persistence, right? Which is about using multiple open source, multiple databases to store your data, right, where they fit less. Now, something I would also encourage you to consider here is, while this is true, a lot of large-scale applications are usually using multiple data stores, the majority of the applications are also not Google or Facebook. They don't have their teams and resources, and that means their approaches of using tens of different data stores may not be very good for you. Now, how do I like to approach that? What I would recommend? Now, as you look at your organization and the development teams, often you may want to start with one database technology which is particularly good for the project you're trying to implement. Right now, in many cases, that is not going to be one database technology. It's very common in the organizations for developers, for example, to choose MySQL or MongoDB for to implement the main applications, but at the same time, your data science team may want to use something to Hadoop to essentially analyze the same data, right? Because Hadoop has much better integration with their various machine learning frameworks, and also because it can crunch through massive amount of data together, right? But I would start with simplicity in mind and really add the more technologies when they are essential, right? And understanding what these the technologies, they also come with complexity and so on. Now, in this case, it's good to understand, though, what sometimes adding the new technology may be better choice and less engineering cost than trying to use technology for something which is not a great fit. To give you an example, if you are looking to get, let's say, some visualization of certain data and some nice dashboards for unstructured data, let's say from your logs, often you can get results much faster with something like Elasticsearch than trying to re-implement the same kind of functionality what it has out of the box with Elasticsearch and Kibana in MySQL. That is especially true those days when it's very easy to roll out the database as a service implementation. So you don't have to become an expert in the operating database technology if you want to use that. Another important thing about choosing database technologies is what there is safety in numbers, right? So what that means is you want to choose the technology which everybody else is using, right? Or as many technologies are, as many people are using as possible, because it's most likely to go into the most battle tested, and also you will be able to find a lot of experience if you run into trouble. If you're using something very exotic, you both have a much higher chance of running into the trouble, as well as finding somebody to help you along the way. So I think that is a second important thing to consider. Now, of course, there are some use cases when you're doing something exotic or have a very high performance requirement, right? You need some optimization for some very specific case, and in this case, you may want to use those new and maybe not very common technologies, but understand the risks which come with that. In this case, I also like to point out, right, if you are looking to reduce the risk and build kind of reliable applications, then often you want to stick to the technologies which are boring. In my practice, I have seen so much time when somebody would get very excited about this very new technology which just comes out. They would build the application on it, right? And then it can be very exciting, and then something happens to that technology, right? Either that has some operational problems, or there can be some business problems. Like, for example, I was myself very excited about the technology called RethinkDB, right? That was a very nice document store engine, right? With a lot of very bright ideas, but you know what? That wasn't very popular, and in the end, that company ended up going out of business. And while there is some open source work still continues, for majority of RethinkDB users, that was a big problem, right? Because if you were counting on having open source, having commercial support, you wouldn't get that. Okay, so with that, if you say your goal is to choose a relatively small number of technologies you can support, of boring but popular open source databases to build your application, right, which makes sense for you and not for giant companies like Facebook. You probably heard a bunch of buzzwords as we related to the database engines, and here are some of them. Now, if you look at the databases, they like to put themselves into kind of those two big group, right? One is relational databases. Also, you can see them called as SQL databases. These are database technologies like MySQL and Postgres, which generally provide a relational data model, and you can operate them through SQL language. And there are other NoSQL engines. And the NoSQL, unlike relational engines, this is a large family of databases which really can have all kind of different models. Here are the most common examples, right? If you're looking for key value store, then Redis would become an example. For document store, that would be more MongoDB. If you're looking at wide column store model, that would be Cassandra, right? And so on and so forth, right? And all of those data models, they do really have some great use cases, then you would benefit from them. Another interesting thing is what you see a lot of cross-pollination happening between the different database technologies. For example, if you look at MySQL, Postgres, right, even SQLite, all of them add some sort of document storage support, right, or JSON interface and so on and so forth. And in MySQL case, even their special protocol, right, with CRUD language, which is quite similar to what MongoDB has. Now, if you look at the many other databases, they also provide either SQL or SQL-like language support, because SQL is so ubiquitous, right? That can be provided either directly, right? For example, the Cassandra provides a CQL, right, which is kind of somewhat similar to the SQL, right? Or in case of MongoDB, right, you can do that through their BI connector interface. But in general, I think it's understood by everyone what the SQL is, or SQL-like language is key for accessing your data. Now, let me show you a couple of examples in this case, the relational and non-relational structure. Right, so if you look at the relational structure, right, that means our data, pretty much all of the data is stored in the table, and then those flat tables, they have relationships between each other, such as foreign keys. And to retrieve that, we're using SQL, which is that would be example. That is actually the example of a query from TPCC, the benchmark, right? Your typical SQL query. So relational variants, right? When you look at the relational storage engines, there are a number of them you can split in different groups. First is a row store. And row store is good for your what's called OLTP workload, right? And you can think about that as majority of your conventional web applications, right, or internet applications, where you have to read a few points, maybe modify your data a little bit. So, for example, you have an application which, user puts an order in, right, or you are, getting the blog post, right, and then you are adding the comment, right, or something like that. These are all applications which touch a relatively small number of rows, right, and then they access and modify data relatively randomly. Now, in terms of a row store, they're also all not all created equal. There are some of the row stores which can be better for read workloads, right? We call them read optimized storage engines, and they're typically based on the B-tree storage engine, right? Let's say in a MySQL space, InnoDB is your classical read optimized storage engine. And then there is another class of engines, such as MyRocks, which is based on LSM trees, or TokuDB, which is based on fractal trees, which are slower than InnoDB on reads, right? Especially in the worst case scenario, but which scales much better if you need to ingest larger amount of data. And for certain kinds of applications, especially modern applications like Internet of Things, those storage engines can also be very interesting. The whole another class of storage engine exists in relational databases are your column store engines. And the column store engines is good for mass data analysis. That's where you can load the data in bulk, and then you do some reporting and analytics. Now, if you look in the open source database space, there is not as much the storage engines which exist in this case. We see Vertica, not obviously non-open source, but a very common storage engine in this case, as well as ClickHouse and MariaDB column store would be example of column store applications. Now, moving on to the next one is the document store. Now, if you think about their document, those are typically based on some sort of a structured document, most commonly JSON, right? And you can see in this case, you can have the fields which pretty much corresponds to the columns you can have in your relational database, but you also can have a more complicated documents, such as you can have arrays as this in this example, right? Or you can embed the other documents, right? For example, you could have array of other documents built in. Another questions you often want to answer as you consider the databases. One is this technology which is disk-based or memory-based, right? In the recent years, there have been a lot of rise of in-memory data stores, which can really optimize for a use case when all the data is in memory. And for that particular use case, they can be faster than applications, than systems which can go to a disk as well. Now, the good thing is, or an important thing is to figure out in this case, even if your data store is designed to have a data store on disk as well, it will often, well, it's all probably even always, right, perform much faster if the data can be cached in memory, right? So, for example, if you look at InnoDB, a storage engine with MySQL, if you have a data which is stored in memory, it can do more than 1 million of a primary key lookups of the data in memory, which is probably not exactly amount you can get from Redis, right? Redis can get you more than that, but it is still very fast for large number of applications. Another question or things to consider is, how is this system designed? Is it designed for your single node operation, or is it really on itself a distributed system? To give you example, the MySQL is pretty much a single node database, right? You can put multiple of a single node together, instances together, and make them to replicate to each other, right? Or even set up some high availability. But by the initial design, it's based on a single node. Query execution, for example, is really limited to a single node unless you're doing some unnatural things. On the other hand, such system as Cassandra or Hadoop, they have been designed to really operate with a large number of nodes from the very beginning, right? And for that has a very different structure and properties and so on and so forth. Okay, so let's talk about the application data model, right? That is, I think, you need to ask yourself what data model your application fits best, right? And also consider the operations in this case, right? Because that's is an important part of the application. Now, one thing which I find interesting in this case is really considering the whole application lifecycle, right? So in many cases, for example, creating the application is first version and a prototype, move fast. This is the case when your document store is very helpful. Now, in this case, in other cases, when you have a long life cycle, you can say, well, we want to make sure this application is going to live for 10 plus years. We're going to maintain it, maybe kind of change schema, add many queries, connect different applications maybe to the same data store. And in this case, you may have a whole different set of requirements came in where relational data model would be more important, right? And here I think is an interesting cases you can hear both from relational databases as well as your non-relational stuff. Your non-relational database advocates will have a lot of examples from you, and you can say, hey, those guys have implemented their system using relational database, but then we had to go to a non-relational one because guess what? Relational databases don't scale, right? On this, from this extent, you can also have relational database advocates saying, hey, those guys implemented a basic prototype for application using document store, and then over time we found it's very hard to maintain over years, so they essentially rewrote it using relational databases, right? And obviously you will find people which over time choose to go to one direction or another. Now, the second thing, of course, you want to understand is a scale, right? Is vertical scaling going to be enough for you, or do you need to have a horizontal scaling, right, where you have many systems? Now, and of course, the horizontal scaling is better, right? It gives you more possibility, right? You couldn't be able to build, Facebook or Twitter or any other popular servers, in this case, on vertical scaling alone. There is no single server out there which could run whole Facebook, right? For example, right, which exists right now. But for a lot of medium-sized applications, your vertical scaling may be just good enough, right? Wherever you take a database like MySQL or Postgres, you can have a database of multiple terabytes in size and have hundreds of thousands up to millions of queries from their single node, which is good enough for vast majority of applications out there. By number, of course, right? Not by the applications which are the most famous out there. And that is a question you should ask yourself. So another thing is to understand here is what in the end you can make any technology to scale, right? It's a question about the efficiency which you have to think about, as well as amount of pain for your engineering team. Now, I mentioned a few times today here a company like Facebook, right? And we know what the Facebook really implemented massive scale out, but at the same time, we also know Facebook for a lot of critical applications run MySQL, right? So we did implemented MySQL scale out. It just took them more time and effort because we had to do that manually. And that is what many other systems which are powered by MySQL or Postgres and other databases which have not been designed for at the outset to be horizontally scalable had to do. So it is possible, right? And I should also mention what there is work going on even in those kind of systems to make it less painful to scale. So, for example, for MySQL, we have technology called VTES, right? Open source technology, which you can use to simplify sharding. For PostgreSQL ecosystem, there is a Citus data, which offers you PostgreSQL sharding with a lot less pain. And that is just technologies I'm aware about. There are probably some more if you find them. Now, I think it's also important what it is not just about the development, right? You also want to, while getting developers being very productive and faster, that is important piece, but there are also other things that you may need to consider, such as your technology long-term viability, right? I mentioned that can be a problem sometimes. So your availability of commercial support, which may be important for you. There are a lot of applications which have been developed with developers entirely self-support or doing, relying on community support when they need to, but many organizations with more business critical applications, they prefer to have a commercial support. Your corporate policies, right, and especially in terms of compliance, various things like security, auditing, encryption, right, and what's not, maybe quite important as well. Okay. Now the second thing, second of this talk, I wanted to spend a little bit more time talking about the open source, and I think that's especially timely recently, right, with all the developments in the open source space. Now, as I want to point out, I am not a lawyer, right? So do not expect 100% correctness in this case, right? And if you say, oh, you know what, that is not 100% correct, Peter. Well, yeah, I'm not a lawyer. I'll share you my general understanding. Don't hold me accountable to that. Now, if you when you talk about the open source, right, or we talk about the free software, it's good to point out that while those terms are very similar, they are really come from two different and even kind of somewhat competitive organizations, right? Free software comes from Free Software Foundation, and your open source comes from Open Source Software Initiative. Right now, while probably both of them would not like me saying so, I believe for a lot of practical users, those terms are quite interchangeable. And with that, I would like to talk about the open source software, which term I use, but I will use free software with 4 essential freedoms, what we look, right? And these are, I think, what defines if open source, if a software can be called as a free software or not. Now, I chose this list instead of list from Open Source Initiative just because it's only 4 freedoms, and Open Source Software Initiative defines the 10 items and criteria which didn't fit in the slide yet. Now, here is another image I took from Wikipedia, which I think gives a very good good indication about the landscape of the licenses, right? And really the whole landscape of open license, open source or not, right? And we can see what in terms of rights on the copyrights, right, or on the licenses, they can range from all rights relinquished to pretty much all rights retained, right? If a software is in the public domain, then it's kind of free for all, right? And there is not as much software in the public domain, but there is some. For example, SQLite makes a claim of really just releasing the software to a public domain being the most open out there. Then there are non-protective open source license, something like FreeBSD. Oh, not FreeBSD. The BSD license, right, or Apache 2.0. We also often call them permissive license or liberal license. Then there are protective open source licenses, also referred like a copy left licenses, right, GPL or AGPL. Then there is a proprietary license, then, well, not open source at all, right, but at least somebody gives you the right to use their IP, their technology, probably in exchange for money. And then finally, there is a trade secret, which is saying, hey, you know what? We have written that software. We're not going to give that to you to use at any conditions at all, right? We retain all the rights. So I think that's a very good way to understand the landscape of a software. And as I mentioned, the open source licenses, they come in two big groups. At least what you should care about. One is your restrictive licenses, GPL or AGPL, also called copyleft licenses. And what those licenses do is they restrict non-open source distribution of derivative work. So for example, there is MySQL. We as Percona have created Percona server, which is derivative work of MySQL, and we have to distribute Percona server as open source. We can't create a proprietary version of Percona server because it's based on GPL MySQL, even if you would want to, right? Now, if you look at permissive licenses, something like a BSD, Apache 2.0, MIT, and so on and so forth, right? Those licenses say, hey, you know what? You can take the software, base some other software on it, and you can release it under proprietary license if you want to. So, for example, unlike MySQL, PostgreSQL is licensed with permissive license, and this is why there are so many proprietary PostgreSQL forks available out there, right? Because you can just add something to Postgres and release that as under your own proprietary license, right? And nothing would stop you. Another interesting thing, which comes to your copyleft licenses, is how a network is treated, right? Then GPL was originated. Nobody was really thinking a lot about the as a service thing, right? So it was all about derivative work, and then you distribute that as you ship software to somebody. In a modern world, cloud world, there is a lot of distribution which happens through as a service, right? So for example, think about all those database as a service technologies like Amazon Aurora, right, or Google Cloud SQL, and so on and so forth, right? Now, with GPL, this is not considered distribution. And that means the Amazon, Google, Alibaba, Microsoft, right, wherever they can take their GPL-based software, they can customize and enhance it, and then make a cloud version available without actually distributing the source code, right? And that's what GPL allows, and that is what AGPL license restricts you from doing. In the AGPL case, if you are providing the database as a service, right, or similar services on a software, on a modified version of a software, you have to release the source code. The third thing you have to think about open source licenses, right, or open source projects is a governance. We can see some of the software has a community or foundation governance, right? Think about Linux. Apache Foundation has a lot of projects. Kubernetes, Linux, right, and what's not. These are all community foundation-driven projects, and then there are also some other open source projects which have a commercial entity behind them and know some foundation-driven upstream. MySQL and MongoDB are probably your most common examples. Now, you may say, well, you know what, it's much better if an open source software is a foundation driven, right? Because well, not a single entity controls it, right? But in reality, though, when you have a foundation, then it often becomes hard for companies to find somebody to work with and say, okay, so can you give me a guarantee what if I pay you money, you will implement that feature and that will be available in your software? In case of foundation, a community, you typically cannot guarantee that it will be subject to the voting and debate, right? And this is why when you have the open source, community-driven or foundation-driven projects, you typically also have one or several vendors, right, which offer you multiple distributions. Linux is the best example, right, in this case. While Linux itself is a foundation-driven, there is a Red Hat, canonical with Ubuntu, right, and also a number of other commercial distributions which exist, right, and which really provide the interface to a commercial relationship many companies are looking for. This comes us also to the commercial services, right? Now, not every open source project has commercial support and services available, which may be important for you. Now, what is interesting in this case is when a software becomes popular, typically one or several vendors appear, right? So for example, in the early stage, technologies such as Hadoop or Kafka, we didn't have any vendor, right? But then they become popular enough, then companies appeared, right? Like such as Cloudera and Hortonworks for Hadoop, right? Which to provide the supporting services around this ecosystem, and now these are publicly traded multi-billion-dollar companies. Now, when you talk about the open source, right? As a practical basics, right? You may be dealing with a vendor, and there are going to be a lot of different conditions. Maybe some things come on different open source licenses. You may hear about the open core and other things I'm going to talk about. The practical question you may want to ask if you're dealing with an open source vendor is this one, right? If you're saying, hey, we're in an open source space, you can ask, well, if I stop the subscription, something is called support, something is called enterprise subscription, what do I have to give up, right, if I stop paying? And if a software is truly open source and completely open source, the answer should not be in the software. It's maybe something, well, you are going to lose access to our team, right, support team, or access to our, let's say, knowledge base or training, right, and so on and so forth. But you can keep still same using the software. That would mean software is open source. If you hear something else, then that means there is probably some trick out there. Now here comes to the next point, which is about open source as in marketing, right? Now, as I started this presentation by saying is it's pretty much clear for everybody what everything being equal, open source is better than proprietary software. And that is why a lot of people want you to market what they have something to do with open source, while really that's being not the full story. Now, do not get me wrong, right? Especially as an entrepreneur, I do support all the software license methods. You guys have building proprietary software. That's fantastic. It's software as a service, even better. But what I really dislike is bait and switch and pretense, right? I like to hear it how it is, and unfortunately, in an open source case, that is not always so. One thing which you often hear is people talking about the open source software, but what they really sell you is the proprietary, better, improved enterprise version, right? Examples in this case would be MySQL and MongoDB, as well as many other companies which tell what they are open source database, right? None of them call themselves open core, but in reality, they are, right? So I think it's important to understand the difference. Another difference that I see a lot is the open source compatible. In this case, that's really proprietary closed source or cloud software which promise compatibility with open source software, right? For example, many cloud vendors, they fall in this group. We have a software which is compatible with open source, at least in terms of what you can migrate from an open source software to that software, right? And but in the end, it's not open source software, right? And but it may be you may be believing that there is some open source connection out there. The next thing, and that is, I think, is very important to understand. There is a huge difference between the open source and source available. What is a source available? Source available means you can have access to the source code, right? You can see it. So for example, if I go ahead and upload something on GitHub, you will see it. That will become source available, right? But that doesn't mean I, as a copyright holder, have given you any rights to use that software. And many developers do not quite understand this difference. And for that, it is very important to understand you're not just accidentally grabbing software you're not supposed to and using that, right? That problem has become so severe. There are a number of companies such as a Black Duck or Palamida, which have a whole business of being able to audit your code base to understand where different bits and pieces came from and what license it was originally on, right? And if somebody took a piece from GitHub and it shouldn't have, right, and it doesn't have a proper license, then that can be flagged and alleviated. Now, the first, the source available business concept, right, exists for quite a while. Back in 2001, I think, where Microsoft came out with a shared source initiative, right? So that is not really new. What I think is maybe more new, right? I haven't seen that before, is really having a business models which are using their deception in this case to this regard, right? Now, if you're not being careful enough, you can go ahead and install the software, right? Which are not going to tell you what that is. Not open source software, and then when you have been using that software for a while, you may get in touch, right? Or they may get in touch with you, the helpful sales team, and tell what you are out of compliance and they require you to pay some ransom money. And you wouldn't have a lot of choice at that point because you would be running the software, have no right to do so, right? Like, for example, I've seen the example recently where you can go and connect to MariaDB repository, where you can get the MariaDB server, which is GPL, right, as it has to be, but you also would get max scale, which is a business source license, which you typically wouldn't have permission to use unless you are a subscriber, right? And that repository is something which you can very easily have access to and use for use by mistake. Now that comes us to the description of a couple of open source like licenses, right? One is a BSL, or business source license. You can think about that as an open source eventually, which says, hey, and now this software is not open source, but you know what? It's only for some time. In the future, in a 2-3 year time frame, this software will get open source, so you don't have to be locked in forever. The reality, of course, in this case, is what by the time this software becomes goes in the open source, it's long unsupported, probably has some known security holes in it, and so you usually wouldn't have no choice but run the new version of software, which is still pretty much proprietary, right? So while there is some claim what we sell is almost as good as open source, I believe what that is not much better than proprietary license, and in my case, in my opinion, is actually much worse than open source, where in open source typically there is a well-tested secure the community edition what you can use, right, if it fits your needs. Another recent trend is appearance of what's called the commons clause. The name implies that something is pretty benign, right? No problem at all. I think there is a intention there, their correspondence to the Creative Commons, the license which are used for content. And this is something which is not a license itself, but is kind of a couple of paragraphs of text which you can add to your open source license, which will make it completely not open source at all, right, in spirit. So for example, you would find some of recent changes with some of the Redis models, or dgraph have switched with Apache 2.0 with this commons clause, right, which again make it look like, oh, that's Apache 2.0, right, and don't bother about this fine print common clause, but that is really non-open source license, and I personally would much rather see them name it something else, right? Don't use don't waste a good Apache 2.0 name with commons clause. What commons clause does is restricts you getting the commercial services from anyone but the copyright holder, right? And that pretty much creates the vendor lock-in for you. That means you cannot really hire some contractor, right, to fix the software if it breaks, right, which I think is a pretty fundamental practical freedoms open source software provides. So you may ask me where's Percona stands for all of that stuff. Well, yeah, I'm you can probably see me being so much pro open source software because all software we distribute is 100% free and open source. That is obviously fundamental value of our value proposition, and we think that is a very good proposition for our customers and the community as a whole. We do not provide any so-called better enterprise software version, right? We provide one software version which has a lot of enterprise features and enterprise quality, but it is 100% free and open source. And we don't play any games and tricks like common clause or BSL. We just don't do that. So as a summary, I would encourage you to really understand requirements you have to open source software. What kind of license, proprietary, do you need permissive license, or is copyleft license good enough for you, right? Or you have to make sure what you have, understand that, or what kind of the commercial support you need, if you need here. And also, as you work with open source vendors, understand what you are getting and what you really get as an open source software and which is not. Finally, I wanted to remind you we have a Percona Live conference coming up in Frankfurt, and there are remaining last few days. You can get the absolutely best ticket pricing with early bird rate until September 9. Okay, and with that, I am happy to take some questions if there are any.
Oh, great. Thank you so much for that, Peter. All right. Our first question is, can you talk about polyglot persistent model? How many industries have adopted and the success rate?
Okay, polyglot persistent. So what polyglot persistence means, right? That is like one of the terms which people have been using, which talks about pretty much using multiple databases together, right? Multiple data stores. And this is very common now across the industries, right? So I would say if you look at the larger scale application, large enterprises, very few of them would have only one data store, right? And even more, only one type of a data store. Like many of them would use something like you have a relational database for your OLTP applications. Now maybe data is being shipped through Kafka to Elasticsearch for your full text search needs, and then you also have some data being shipped off to Hadoop, right, for the various data science needs.
Thank you. Okay, this is a two-part question.
Okay.
We're using Vertica, having a 1.9 PB cluster. Is there an open source that might replace it? And then the addition to that question was, what kind of analytics for open source databases do you recommend?
Oh, okay. So let me. So if you're looking at the Vertica, right, there are a few things you can look into, right, which I know people had success with. One is Hadoop ecosystem is very commonly used in this environment, right? And depending on the exact task, you may be able to use tools like Spark, right, or Impala or Presto, right? There are different tools which have a different kind of trade-offs between the SQL they actually support, right, and performance characteristics. You may also look at the technologies such as MariaDB and the ClickHouse, which I mentioned in the presentations. We have seen those to be very successfully used for some applications as well.
Thank you. Let's see. Our next question is, what do you recommend deploying all of these open source databases?
Where is that?
What? So, I guess maybe what open source database do you recommend to deploy?
Okay. Well, as I mentioned, in this case, there are number of choices which are available, right, and which you can which exactly database you should choose depends on the application. That's the whole point of this presentation. There is no one database which is best for absolutely everything.
Sorry, you were right. It's where do you recommend to deploy these databases?
Where? Well, so if you look at now, right, a lot of deployments are happening in the cloud, right? And we believe that a lot of major cloud providers, they have a very good technology for you to deploy that. For many of those cloud vendors, you also have a database as a service choice for many database engines which you surely can use. Now, of course, in this case, you are kind of have to pick your choice between the convenience, right, and really having everything as an open source software. And then what we also see increasing interest coming up is with Kubernetes environment, right? We don't see that being that commonly used in production yet, but that is really very, I think, very interesting model, which allows to have a very high automation for deployment of open source databases, and also have the same interface for deploying them wherever on the premises, right, in public cloud and the private cloud. So that looks very exciting.
Thank you. I'm going to squeeze in another question. In what scenarios can we not use cloud for deployment in open source databases?
Well, I don't quite understand the question. Now, if it is open source database, then you can deploy it in the cloud, right? If a database technology says, hey, you cannot deploy it in the cloud, then that's not open source, right? Just by definition. Right now, if you look in terms of the performance details, they are depending on what kind of database system you have. Some of them may be better designed for supporting cloud, some worse. But in reality, majority of commonly used open source databases are very widely deployed in the cloud, so you should be safe.
Yeah, thank you. Well, we are getting close to the top of the hour. Thank you so much, everybody, for attending today's webinar. Thank you, Peter, for presenting today, and we hope to see you on future webinars, everybody.
Okay, thank you, everybody.